Hello, my name is Skylar Smith, and we're going to talk about pyranometers from Apogee Instruments, choosing the right sensor for you. So we're going to cover today what the pyranometers measure, the difference between our different series, the 100, 200, 500 series, the output options for these sensors, and what the SP420 is, and then we're just going to list a couple of common applications that people use our pyranometers for. So the pyranometer measures shortwave radiation, and it does it in units of watts per meter squared. That's also known as energy flux density. All of our sensors are calibrated to match the spectral response of high-end blackbody thermopile pyranometers. There's a link there to the traceability, but what we want to show is what that means. So here in the background, we have the solar radiation spectrum. You can see the red and the black lines there. So our SP100 and 200 series measure from 360 to 1120 nanometers. That's what the spectral range is. The spectral range of the thermopile pyranometer is 385 to 2105. But the range that all of our pyranometers, both the silicon cell and the blackbody, is from 285 to 2800 nanometers. And the way we do that is we use these ISO classified secondary standards. And these are the standards that we reference all of our pyranometers to. And then we send those ISO classified pyranometers into the National Renewable Energy Laboratory to be calibrated there, which then references back to the World Radiometric Reference in Davos, Switzerland. And so that's how we're able to calibrate our sensors that have a smaller spectral response to match the output of high-end blackbody thermopile pyranometers. So what is the difference between the thermopile pyranometer and the silicon cell pyranometer? Well, there's an excellent video put out by my colleague Mark Blomqvist, and you can click there, click up in the corner, and you can watch that video, and that's going to explain the advantages of the thermopile pyranometer. But to break it down simply, in clear sky conditions, the silicon cell pyranometer works great and is going to give you very accurate readings. In cloudy conditions and overcast conditions, the thermopile pyranometer is going to be the best, most accurate sensor for you. So if you know about the shortcomings of the silicon cell and are aware of that, then that one might be what's going to work for you. But in all applications, the thermopile is going to give you that more accurate data. And then down below is just a comparison chart. You can click on that if you want to see that on our website. We also are going to have that same chart on the video here in a minute. So the SP100 series, the silicon cell based spectral response we talked about, it's self-powered. It means that the output is between 0 and 350 millivolts. And so the SP230 has that same output where it's self-powered, but it has a heater built in so that the rain, the dew, the frost can be melted off with just a 12-volt input. All of these sensors are interchangeable, the SP110 and the SP230. So if you have SP110s right now, but you'd like the heated version, the SP230, you can just change those out and they'll have the same calibration factor of 5 watts per meter squared per millivolt. The SP200 series has the same sensor as the SP100. It's just the amplified versions. So we have a 0 to 2.5 volt version, 0 to 5 volt version, and 4 to 20 milliamp version. Those do require to be powered by 5 to 24 volts. And they're interchangeable by type. So an SP215 is going to have the same calibration factor as another SP215. The SP500 and SP600 series, these are all thermopile sensors, the larger spectral response. They're self-powered, and so they have a smaller signal than our other self-powered one, 0 to 114 millivolts. Built-in heater in both sensors. And then each one does have an individual calibration factor, so they are not interchangeable like the SP100 and 200 series. If you change the sensor, you do need to change the calibration factor as well. And this is that chart I referenced before. You can pause if you want to look at something specific. We're just going to go through and look at the output and the model number. So for the SP110 is a 0 to 350 millivolt output, SP110, 0 to 2.5 volt output, SP212, 4 to 20 milliamp output, SP214, 0 to 5 volt output, SP215, 0 to 350 millivolt with the heater, SP230, And then the thermopile pyronometer, the SP510, is the upward looking model. And then these are approximate, the approximate sensitivity on that. All right, the SP420 is the same silicon cell sensor as the SP100 and SP200. It just has a USB output so that it connects straight to a computer, and you can use the computer as the logger. And so it requires a computer or tablet to display the output, and then it also comes with the Apogee Connect software is included when you purchase this sensor. This is an example of what the software looks like. You can see the instantaneous output here just after you have the software downloaded and it's connected. And then if you want to do logging mode, you just set up your logging sampling interval, logging interval, and then it will show you the logging information over there, and then where that logging information is saved is right here in a CSV file. So this is fantastic for residential homes. If people want to put this up on their rooftop next to their solar panels and see the amount of available solar radiation compared to what their solar panels are producing. So a couple of common applications, just what I just mentioned there. Evapotranspiration calculations as far as the amount of solar radiation being calculated for that. Weather station solar irradiance, so you can see the amount of solar radiation hitting a particular spot. The energy balance, this would use our SP510, SP610, and that would help you calculate the amount of available, or the amount of shortwave radiation coming in and the amount of shortwave radiation leaving. And then to estimate the solar thermal load on commercial building. We've had some customers buy these and put them inside windows to see what the solar load is on a particular room that's covered with glass, to see how that's affecting the temperature. Well, thank you very much for watching our video today. If you have any questions or comments, you can email me, you can comment below, and be sure to click here to subscribe to our channel. Thank you.